Hi, this is Ramprasad Pujari. Welcome to the first session of DSP lecture series. In this series, I will talk about some important topics discussed in DSP course. Today, this is the first session. We will have a discussion on one-dimensional convolution, and this is going to be a very short video where we will begin with mathematical expression for one-dimensional convolution sum, followed by the some of the steps that you have to follow when you compute convolution sum, and after that we will end this session by verifying using some of the tools like Matlab and Python. The mathematical expression for convolution sum is shown here. So this is the mathematical expression for y of n. Y of n is the system response as shown in this particular block diagram. You have x of n, which is the input to the system, h of n is the impulse response, and y of n is the response or output of the system. So you can obtain y of n when x of n and h of n are given, provided the system is LTI. In this video, I am not talking about what is LTI, and I will also not derive this particular expression. This expression will not be derived. So we'll try to compute y of n when x of n and h of n are given, and along with that we will also try to verify y of n using some tools. This is the convolution operator, this is the operator, and convolution is commutative. It satisfies commutative property, so you will be able to rewrite this expression like this by swapping x of k and h of k. I have swapped them, and you will get the same result. You can use any one of the expressions to solve for y of n. There are two methods, for computing y of n from x of n and h of n. One of them is graphical method. Second one, you can solve this any one expression to get y of n. So I will use mathematical expression. I'll try to solve it. If you look at any of these mathematical expressions, you see that there are four different operations that you need to perform. And what are the four operations? Uh, if you look at this expression, you have time shift operator, that is n. You have minus k in place of k, that means time reversal. Then you need to multiply these two sequences. You have multiplication. Then you need to sum up this product. You need to sum up this product. That means summation is there. So four operations need to be performed to get y of n. This is the mathematical expression that we are going to use for computing y of n. And these are the two sequences which are given to us. X of n is given. X of n has a length 3 and time range n equal to 0 to 2 with an amplitude 1, minus 1, 1. Similarly, we have h of n here, and this has an amplitude 2 here, and 2, 1, 2, and minus 2. And if you look at the time range or time interval, n equal to minus 1 to n equal to 2. So what we are supposed to do, the very first step is to modify this limit. If you look at the mathematical definition, then k equal to minus infinity plus infinity, that is the limit given for x of k. So we need to look at x of k and modify the limits. So I see that it starts at n equal to 0 to 2, so my range will be from k equal to 0 to 2. And so I modify the limits, rewrite the expression again, and after that what I do is I expand this summation series. So I get three terms here. X of n has three samples, so I'll be getting three terms here. Then I substitute for x of 0. I know the values of x of 0, x of 1, and x of 2. I substitute them, so I get a new mathematical expression. This is the expression which we are going to use to compute y of n. Now we need to know two things about y of n. One is what is the length of y of n, how many samples you are supposed to compute. That is the first thing. Second thing you should know is what is the time interval for y of n. What is the starting time instant and ending time instant for y of n. First we'll find out the length of y of n, and for that we can use this particular formula L plus m minus 1. L is the length of x of n, that is 3. M is the length of h of n, that is 4. Hence we get the length of y of n as 6. So you need to compute 6 samples, but we also need to know what is the range for n. So for that we look at the lower limit for n for both x of n and h of n. So lower limit, it's 0 for x of n, it's 0 here, and it's minus 1 here. We just add them, 0 and minus 1. 0 plus minus 1 is minus 1. So hence y of n starts at n equal to minus 1, and then you have 6 samples. So it goes up to 4. So we need to compute 6 samples by substituting n values from minus 1 to 4 in this equation. So that we will see in the, then we'll get a result like this. We're going to get 6 samples. The first sample is 2. First, the amplitude of the first sample will be 2. Then the second sample will have an amplitude minus 1. So then you have 3, you have minus 3, this is minus 3, you have 4 and minus 2. So these are the samples of y of n. Now the last task is to verify it. That we will see in the next slide. So let's verify the convolution result using some of the tools. I will use Matlab first. As you know that the Matlab has a built-in function, that is conv, and you need to pass these two sequences as input parameters, xn, which is nothing but x of n in my case, and I have defined here, and h of n is the second sequence that you need to pass into this convolution function. So you will get y of n as the output, and you can see that there are 6 samples here, L plus m minus 1. So that is the length of y of n. Now you also know that convolution is commutative, so if I exchange this h of n and x of n, still you get the same result as shown here. Okay, so conv is the function that you can directly use in Matlab to verify this. Before looking at Python code, there is also a simple math rule that you can follow to verify your result. Now, the student can make use of this simple multiply and add method to check whether the result is correct. So they will write x of n, which has 3 samples shown here, and then h of n, which has 4 samples over here. Then they will multiply with the samples and write it down. You get intermediate products like this. Okay, so you get different products, intermediate products. Then you add them. This is 2, this is 1 minus 2, that is minus 1, 2 minus 1 plus 2, that is 3, and similarly you can calculate other values. Okay, so you see that this result is same as that of Matlab. So hence we have verified this. So now we will verify our result using Python IDE. You can use any Python IDE for this exercise. I have used Jupyter Notebook for this because I am comfortable using it. So you need a Python library or a module called as numeric Python for convolution. So I have installed them already. I have installed NumPy and I have imported here onto my notebook, and here I have imported it. This is the first line of Python code. Then I have defined both the sequences. I have defined x of n and h of n. So then I need to use a function called as convol. So NumPy has a function called convol. I can pass these two sequences as the input arguments. So I'll get the result. Then I can print it. I can print it here. And this is just to check whether convolution is commutative. I got both the result and I can see that they are exactly matching. Okay, so we have verified our result. So in this session, this is it. What we did is, we started with mathematical expression. We computed y of n by solving the mathematical expression. I have briefly explained you the steps that you have to follow. And after that, we have verified using three different methods, the two tools, Matlab and Python, and there is a simple math rule that you can follow to verify the result. Okay, then we will meet during next session. Thank you.